Hello, good evening. Welcome back. In this video, we will introduce database design using ER model in chapter 3. In this chapter, we will use ER modeling to model data, to identify entities and their relationships, to describe entities using attributes, multi-valued attributes, derived attributes, and key attributes. We'll know the difference between strong entities and weak entities. I'm going to break this chapter into 3 videos. So that's one video is on ER modeling, and the other one is on the enhanced ER modeling. And the last one will be on the functional dependencies and normal forms. Before you can store data into a database, you have to define tables, the structure for the data. How tables are defined will impact the database quality. So that means the efficiency and how you're going to process data quickly and store data using minimum space. For example, suppose the department table is defined as shown in this figure 3.1. So let's look at the department table. It's here, right here. So we have this department ID and department name. So this is the CS. The name is computer science. And this is the head of the CS department, the ID. And this is the college. And this is the name of the college, science college, and this is the education college. So here, this is science, and when this college was founded, and this is the dean, and the ID for the dean. Now you're going to see some problems is redundancy. There's a lot of redundancy here in this table. And look at this is college ID. So here you have the college ID and they have the same name right here. And the science, and they have the same, this is the sense the college was founded. So here, and the dean's ID. So you're going to see this, all this data right here, they are redundant. You just need one and for all. So that's the problem. So essentially, it's the redundancy. We're going to eliminate redundancy to improve efficiency. A proven sound methodology for database design is the ER modeling. It's entity relationship modeling, which was first proposed by Peter Chan from MIT. Peter Chan, in his original paper in 1976, titled Entity Relationship Model Toward a Unified View of Data. So this modeling approach has been widely used for designing logical database schemas. The first step to design a database is to understand the system. Know how the system works and discover what data is needed to support the system. Then we're going to obtain an ER model and translate the model into the relational schemas. And finally, we're going to improve the relational schemas using normal forms. So here is the diagram representing the process. We work with the user to identify the system. And we're going to draw the ER modeling. This is a diagram. And we're going to translate the diagram into relational schemas. And finally, we're going to apply normal forms to improve the schemas. All right, so now let's look at the entity relationship model. An ER model is a high-level description of data using graphic representation. So this is on discovering how data is stored, the relationship among data, but not on how data is stored. It focuses on identifying entities and relationships among the entities. So let's look at this word. Hey, what is entities? Entities, actually, I like classes. We are familiar with object-oriented programming, so the entities as same as classes essentially. So what is entity? You can say it entity is this objects with the same type. So this is the entity is distinguishable object. It's object. So it's also, well, let's put it this way. You can say, hey, so entity is object. Object, it's distinguishable object in enterprise. An entity has attributes that describe the properties of the entities. For example, a course is an object in the student information system. The course subject, number, name, number of credit hours, and prerequisites are the attributes for the course. All the courses have the same type of attributes. A collection of entities of the same attributes is called an entity set. So an entity set. All right, I think it's an entity set. It's like our classes. Entity is like objects. Okay, I have to clarify it here. Thank you. An entity class, so it's same as an entity set, defines an entity set. So this is the, it is actually the entity class. It's you have an entity set, and so you have an entity class to define an entity set. So it's and then in the set you have a lot of entities. So those are the objects. An entity class is like Java class, except it does not have methods. An entity is also known as an entity instance of its entity class. All right, so now let's look at the key attributes. What are the key attributes? Key attributes are this. Since each entity is distinguishable, no two entities can have the same value on the attributes. Each entity class has an attribute or a set of attributes that can be used to uniquely identify the entities. In case there are several keys in the entity class, you can designate one as the primary key. For example, you can designate the course title to be the key. So the course title are unique. So we're going to assume that every course has a different title, so that is unique. So we can designate it as the primary key in the course table. Composite attributes. A composite attribute is an attribute that is composed of two or more sub-attributes. For example, the student entity class has the address attribute that consists of street, city, state, and zip code. So that's the address has the comprise of the street, city, state, and zip code. This composite attribute. Now, what is the multi-valued attributes? Multi-valued attributes is an attribute that may consist of a set of values. For example, the course entity class has the prerequisites attribute. A course may have several prerequisites. Therefore, prerequisites attribute is a multi-valued attribute. Derived attributes. A derived attribute is an attribute that can be derived from other attributes. Derived attributes should not be stored in the database because they can be derived. So there's no need to do this. And if the other values change, you're going to derive different things. So you shouldn't store it. So like somebody's age, if you already have birth date and you can derive the age from the birth date, so the age should not be stored. And so the age actually changes, and the next year you have different age, so that your birth date is still same. So this is a derived attribute should not be stored in the database. All right, so let's look at this ER diagram. So how do we represent it? So we're going to represent it using a rectangle for the entity. So this is the entity, let's call it entity or entity class here. This is the entity course. Here's the course. There's many courses, right? Course 1, course 2, course 3, but all together, this is the course. Here is the course. This course consists of the attributes, course number, title, number of credits, prerequisites, and number of prerequisites. All right, so look, this course title is underlined. So that means this is a key, the primary key attribute, the primary key. And the prerequisites here, you have a double over, so it means this is a multi-valued attribute. And this number of prerequisites, it's dashed over, means it's derived. So that's in our notation. All right, so let's look at another one here. As a student, you have the primary key, it's social security number, and his name is a composite attribute. So it consists of first name, middle name, and last name, and the address is a composite. All right, here you have a major, and you have birth date, and look, this age is derived, so it's denoted and using this dashed over. All right, so look at the relational database, and this is the essential, it's to describe the relationship. So now how do we describe the relationship? So we have the relationship classes. An ER model discovers entities and identifies the relationship among entities. A relationship between two entities represents some association between them. So for example, a student taking a course represents here's enrollment relationship between student and the course. A collection of the same type of relations form a relationship set, a relationship class or type define a relationship set. Relationship is also known as relationship instance or its instance class. All right, so we're going to look at this identify it. So here, when you identify it, you look for the verbs in the meaning here. Is here we have for example, a faculty works in the department. So here the works implies the employment relationship between faculty and a department. The entities are identified from the nouns. The entities are nouns and the verbs are form a relationship. Relationships can have attributes just like entities. For example, the enrollment relationship may have an attribute to record when a student is registered for the course. Now, this is important for the ER diagram is the cardinality constraints on relationships. So that really actually determines how we're going to translate the relations into tables. So what is cardinality constraint? A relationship class establishes the relationship between the entities in the entity classes. An entity is one entity class. An entity in one entity class may be associated with one or more entities in the other entity class. A cardinality constraint on a relationship class puts restrictions on the number of relationships in which an entity may participate. There are four basic types of constraints. So first one is 1-to-1. So here's 1-to-1. So there you have here user has account. So there's one user has only one account. So this is the account only belongs to one user. So this is the one here. Now please note that this maybe we have a user who has no account yet. So it has not created a new account. So this is possible. But if you have an account, you always have a user. So this here, this one here, it's in this relationship, account is known as strong participation, and the user is a partial participation. It's not a strong, it's not full participation, it's partial, right? This is full. This is okay. Partial. All right, there's a lot of one-to-one relationship. For example, the marriage relationship is 1-to-1. So you have two people married. So this is the relationship. It's 1-to-1. All right, so here, one-to-many. So this is a one-to-many example. You have department. It's one department has many faculties. So this is one-to-many. So faculty only belong to one department. So this is one-to-many. Now, many-to-many. So this example, student takes course. Student may take multiple courses. So this is one-to-many. A course may have many students taking this course. So this is many-to-one, many-to-one. So many-to-one relationship. I'm sorry, many-to-many, many-to-many, okay. All right, so that's many-to-many. So we have, here's one-to-many the other way is if you reverse it, it's many to one. So here it's one to many, department to faculty, and that's one to many. So if you look at faculty to department, that's many to one. So that's reverse. Okay. All right. So here we're going to have this participation constraints. The participation constraint specifies whether every entity in an entity class participates in a relationship. If so, it's called a total participation. Otherwise, it's called a partial participation. So, for example, we look at the participating of faculty in the employment relationship with department is total. And because every faculty in the department entity class must work for a department, the participating of student in enrollment relationship with a course may be a partial. You may have a student not taking any course at this time. All right, so here, let's look at this ER diagram. Look at this relationship between a student and course and subject. So here we have this is student takes a course. So here's the enrollment relationship. And when student enrolled into the course, so this is date enrolled. And this is a many-to-many relationship. Student may take many courses, many courses may be taken by multiple students, a course may be taken by multiple students. All right, so now the other way here is course and subject. A course belongs to a subject. Here, this is many. So you may have multiple course belongs to one subject. So that's many to one. And this is double line here. It means it's a total participation. So the course must belong to a subject. Now, what do we see here? This is the binary relationship. So this is two entities and form a relationship. Now, in some situations, you may have ternary, or in more than ternary, it's n-ary relationships. And for example, if you have a company provides a product for a project. So this is company, product, and projects, and they're together. Company, this entity involved. A company provides a project, product for a project. So here, it's a company provides, so this is supply, product for the project. So this is many-to-many relationship. And when this happens, it's a date supplied. So here's a company, primary key, the name of the company, stock symbol, the address, and product, the primary key, name, color, weight, and the project, the name of project, and description. So this is the n-ary, this is ternary here. All right, so now let's look at this. What is this weak entities and the identified relationship classes? An entity is called a weak entity if its existence is dependent on other entities. The other entities are called owner entities. In contrast, a regular entity is called a strong entity, just a regular entity, in contrast to the weak entity. For example, a faculty has dependents. Now, the dependent is a weak entity, and that is dependent on its owner. Entity class faculty. A relationship between faculty and dependent is called an identifying relationship for the weak entity. So here's the figure shows this. This is the figure. We have this figure here. This dependent is the weak entity. And the relationship, the identified relationship now becomes this this is double diamonds, and this is the double rectangles. So here, the dependent has a name, may not have a social security number. So because like a newborn, you have to wait for some time to get this social security number. So this is the case. You have a faculty, you're going to use the faculty social security number to identify together with the name of the dependent to identify this dependent. So this is the weak entity. So now we're going to put all things together and look at a comprehensive student information system using ER diagram. So please study this diagram here. I just put all this together, student, course, here's a faculty, department, this is the dependent. So all this together. So that's the system, all this data and relationship among the data, and is a visual representation and using this entity relationship modeling. All right, after this, we are going to translate it into tables. Now, please look at this is the standardized notation. So this is what is the rectangle mean, what is double rectangle mean here, and this is diamonds and double diamonds are this total participation and the partial participation. All right, so here, there's one thing you have to note that, so just like you're writing a program, you know two people write the same program. It's not unique. You may have different ways to write a program. The same thing is ER model. Sometimes it's not unique. It really depends on your understanding of the real world. So you may have a different way. For example, here is we may have this student course. I'm going to have something like this. Student, so here as there's a registration as it's a weak entity, so it depends on the student and the course. So it has so this is, but it's not really good. It's not as good as this one here, student enrollment and the course. So, but it's possible you can write something like this. All right, so now we can do the translation. So this is important, the specific rules for translating translating ER models to relation schemas. Once an ER model is created, you can translate it into relation schemas. And there are specific rules to follow. So those are the rules you need to follow. And translating strong entity class. So this is a regular entity class. And each strong entity class in the ER diagram and becoming a table. So you're going to create a relation schema for it and choose the primary key of the entity class as the primary key of the relation. The attributes are translated in the following sections. We're going to translate attributes. So you're going to simple attributes. For each simple translate attribute, is simply creating a field in the relation. So for example, birth date and email, and so this in the student class. So this is the social security number, phone. So they're all there. All right, so this is for the real simple attribute. And how about the composite attributes? Now, for each composite attribute, you have to create a field for each simple attribute in the composite attribute. For example, here we have the name. You have the first name, last name, middle name, initial. So each of them you have to get a column. So this an attribute for it. All right, so that's the composite attributes. Let's look at this translating the rule for one-to-many relations. So relationship, one-to-many, how you translate it. So this is how you're going to translate. You're not going to create a new table for the relationship. So what you need to do is you're going to select, so this is two. So there's a relation, one-to-many relationship between S and T. You're going to select the one whose cardinality is many, and say this is T as the target. So cardinality. Okay, many, the many one. So for example, let's say this T as a target. Add the primary key attribute of S, okay, whose cardinality is 1 to T as a foreign key. Add the simple and the composite attributes of the relationship class into T. So there's any attributes on the relationship, and it should be added now to the target T. So here, for example, here is here we have this the relationship between department faculty. So faculty belongs to a department. All right, faculty belongs to a department, and the faculty, and this is the one is many here. So the department has many faculty, so it's many is on the faculty side. So here's a faculty. So you're gonna add this here. So faculty secretary number, last name, middle name, first name, and this is anything here for number, email, office, rank, and here is getting it from department and department ID. So when you start this, so it's here always faculty. So now that relationship is now absorbed in this relation, in this table. So this is really good, and so you may wonder why it's this way. Well, this is really good guideline. It really makes sense. You're going to see it later when we look at the functional dependency and normal forms. All right. Translating one-to-one relationships. For each one-to-one relationship type between entity classes S and T, you're going to select the one with less non-participating entities as the target T. So let's say this is T. Add the primary key of S to T as a foreign key, and add the simple and the composite attributes of the relation into T. So for example, here, this owns is one-to-one relationship between student and account. Student owns account. Now, and for the account, and this is actually this total participation is more there. So you're going to use account as your target. So the account has username here and the password, and the student primary key from student social security number, and this since when this account was established. So now this is the this social security number now becomes foreign key to point to the reference to the student. All right, now translating many-to-many relationship. When you translate many-to-many relationship, you're going to create a separate table for this relationship. So here's a relationship. You're going to have this relationship is R between those entity classes S and T. So we create a new relation schema named R. And so here, let SK and TK denote the primary keys in S and T respectively. So we're going to add SK and TK into R, and also add all the simple and the composite attributes of the relationship class and into R. So that on the relationship into R. So now we have this. For example, the enrollment. So between student and courses, student enrolling to courses, we get the student primary key, we get the course primary key. So we get this, the enrollment, you have the date registered, and the grade is from the relationship. It's not here, enrollment. So this is how you translate many to many. So you translate now any relationship. So to this, you have to create a separate table, and to get all this involving entities primary key and plus the attributes on the relation. For example, the supply. So you get the primary key from the company, product, and from the project. This together actually form new primary key in this in supply. So this is then supplied. All right, now translating weak entity classes. For each weak entity class W, create a new relation schema named W, add the primary key of its owner entity class into W as a foreign key, and add all simple and a composite attributes W into the relation. The primary key of the relation is the combination of the primary key of its owner relationship and the partial key in the weak entity. So this is dependent, for example. So you have Social Security number, and from the owner class, and last name, first name, and middle name, initial here, and sex and birth date. So here's dependent. All right, so finally, let's look at translating multi-valued attributes. So what you do with multi-valued attributes, the multiple values there. So you need to create a separate relation. For example, prerequisites. So we're going to create a prerequisites, and we're going to get the use the primary key of the entity here, the course. So this course has prerequisites, many prerequisites that we have now. This is the multi-valued. So we create a relation here, and with the course ID as the primary key, and this is the for each prerequisite ID it's here. All right, that is all for this video. Next video will be on enhanced entity relationship modeling. See you on the next video.